A monster is hiding in our galaxy, so massive that if it were to replace our Sun, its surface would stretch all the way to Saturn, and every planet in between, including Earth, would disappear somewhere inside it. And the strangest part is that this monster was right in front of our eyes for thousands of years, yet we never saw it because it was hidden behind a veil our eyes simply cannot perceive. What if I told you this isn't a story, but reality? This star is so enormous that light, which can circle the entire Earth 7 times in a single second, would take a full 9 hours just to complete one orbit around it. The name of this monster is Stephenson 2-18, one of the largest known stars in the universe. And today, we're going to explore its complete story from beginning to end. Who discovered it, how it was found, what it looks like, and how catastrophic its end could be. So, let's dive straight in. First, for a moment, think about our Sun, because without understanding it, it's impossible to truly appreciate the scale of this monster. Our Sun is so large that about 1.3 million Earths could fit inside it. Every morning, when you see it rise, it looks so immense that we seem smaller than ants in comparison. Our entire lives, our food, our weather, everything depends on this single star. And when scientists measure other stars, they use the Sun as a reference. One solar radius, which is simply the radius of our Sun. Now hold on to that thought and prepare your mind, because the radius of Stephenson 2-18 is approximately 2,150 times greater than the Sun's. That number is almost impossible to imagine, so let's picture it another way. Imagine that our Sun suddenly disappeared, and Stephenson 2-18 took its place at the very center of our solar system. What would happen? First, Mercury, the closest planet to the Sun, would be swallowed almost instantly. Then Venus. Then Earth, our home, where billions of people have lived, where every civilization has risen, and where every mountain and ocean exists, would also vanish beneath the surface of this enormous star without leaving a trace. Then Mars would disappear, and the story still wouldn't be over. Next comes Jupiter, the largest planet in our solar system, so enormous that about 1/300 Earths could fit inside it. Even Jupiter would be consumed by this monster, and the star would continue expanding until its surface reached the orbit of Saturn. Just imagine it. A distance that takes our fastest spacecraft years to cross would exist entirely inside a single star. And if that still doesn't seem astonishing enough, think about it another way. Light is the fastest thing in the universe, traveling at nearly 300,000 kilometers every second. It takes only about 14.5 seconds for light to travel once around the Sun. Around Earth, it circles the planet 7 times in a single second. But to travel just once around Stephenson 2-18, that same light would need approximately 9 hours. Imagine beginning that journey at 9 in the morning. Even at the speed of light, you wouldn't return to your starting point until evening. And if even light feels too difficult to imagine, here's one final comparison. If the fastest airplane ever built could somehow fly around Stephenson 2-18 without stopping, slowing down, or running out of fuel, it would take about 100 years to complete just one orbit. If that flight had begun 11 centuries ago, it would only now be finishing its first lap. That is the true scale of the monster whose story you're about to hear. But now comes the real question. If it is so massive, why didn't we discover it centuries ago? Humans have been looking up at the night sky for thousands of years. So how did a star this enormous escape our notice? The answer lies in the very veil I mentioned at the beginning. When you look up at the night sky, you only see the stars whose light can reach your eyes without being blocked. But our galaxy isn't made of stars alone. It is also filled with enormous clouds of gas and dust drifting through space. These clouds are so dense that they absorb and block the light coming from the stars behind them. Stephenson 2-18 happens to sit behind one of these immense curtains of dust. It is located about 19,000 light-years away from us, and its visible light becomes trapped inside that dust before it can ever reach Earth. That means no matter how powerful an ordinary telescope may be, this star is almost impossible to see in visible light. So how did we finally find it? The answer is infrared light. It is a form of light our eyes cannot detect, yet it can pass through those thick clouds of dust and continue its journey through space. When scientists began observing the sky using infrared technology, the hidden giants that had remained invisible for centuries finally began to reveal themselves. And this is where the true story of this monster begins. The year was 1990. An American astronomer named Charles Bruce Stephenson was examining data from a deep infrared survey of the sky when he noticed something unusual in the constellation Scutum. He found 10 faint stars, reddened by dust, gathered together within a small region of space. In visible light, they were almost invisible, but in infrared, they stood out clearly. Stephenson realized he had discovered a star cluster, a family of stars that had all formed together from the same enormous cloud of gas. That cluster was named Stephenson 2 in his honor. What made this cluster extraordinary wasn't its overall size, but the remarkable stars living inside it. It turned out to contain one of the largest known populations of red supergiants anywhere in our galaxy. A central group of 26 enormous red stars, each one capable of making our sun appear tiny by comparison. But among all of those giants, one star stood apart from the rest. At first, because it appeared to be the brightest, scientists assigned it the number 1. Then something unexpected happened. Its brightness seemed unusually high. Its position appeared unusual. Its motion didn't match the others very well. Because of that, scientists removed it from the cluster entirely. They believed it might not belong to this stellar family at all, but instead was an outsider that had somehow wandered into the same region of space. However, after years of more detailed observations, they reached a different conclusion. The star was added back into the cluster once again. This time, it received a new designation, number 18, and that is how the name we know today was born, Stephenson 2-18. Even then, another mystery remained. How far away was this extraordinary star? That question was far more important than it might sound, because before scientists can determine the true size of any star, they must first know its distance as accurately as possible. If the estimated distance is wrong, then the calculated size will also be wrong. When Charles Bruce Stephenson first identified this cluster in 1990, he estimated that it was about 98,000 light-years away, placing it close to the outer edge of our galaxy. That was an astonishing distance. Then, in 2007, astronomer Ben Davies and his team applied a different technique known as the kinematic distance method, which estimates distance by measuring how fast the cluster is moving relative to us. Their results dramatically changed the picture. The distance was revised to approximately 19,000 light-years, with only small refinements made since then. That is the value astronomers still use today. Stephenson 2-18 lies within one of the Milky Way's great spiral arms, known as the Scutum Centaurus arm. So now we know where this monster is. We know how far away it is, and we know who discovered it. But now comes perhaps the most fascinating question of all. How did this giant become so unbelievably massive? And even more surprising, despite its incredible size, why is it actually so cool? Every star is fighting a constant battle deep inside itself. On one side is gravity, pulling all of the star's material inward, trying to crush it under its own weight. On the other side is nuclear fusion at the star's core, releasing tremendous amounts of energy and pushing outward with equal force. As long as those two forces remain perfectly balanced, the star stays stable, shining quietly for millions of years. Our sun has remained in this delicate balance for billions of years. But stars, like Stephenson 2-18, have reached a completely different stage of their lives. It has nearly exhausted the hydrogen fuel in its core, and when that happens, the core begins to contract and heat up, allowing the star to start fusing heavier elements. This new source of energy causes its outer layers to expand dramatically, almost like a balloon being inflated. The star grows outward until its surface lies incredibly far from its center. And as that surface expands farther away, it cools down. That is why Stephenson 2-18 appears red. Its surface temperature is only about 3,200 degrees, noticeably cooler than the surface of our sun. Cooler stars glow red, much like a piece of iron that first glows red when heated and then becomes white as it grows even hotter. This monster is unimaginably large, yet surprisingly cool. It has swollen into an enormous giant, like an ancient star reaching the final chapter of its life. Its surface is anything but peaceful. Deep inside, enormous currents of hot material are constantly rising and sinking. These giant convection cells are so vast that some of them are larger than the entire orbit of Earth around the Sun. Just imagine a single bubble of scorching gas stretching farther than the distance between Earth and the Sun, slowly rising and falling across the surface of one star. That constant turbulence also causes its brightness to change over time, becoming a little brighter, then a little dimmer, over and over again. But the most important part of this story comes now, because Stephenson 218 is not simply enormous, it is dying. Stars, this massive, live, incredibly fast lives. It is one of the universe's harshest bargains. The larger the star, the faster it burns through its fuel, and the shorter its life becomes. While our sun will continue shining for billions more years, monsters like Stephenson 218 survive for only a few million years, and this one is now believed to be approaching the end of its life. Even now, the star is throwing its outer layers into space. It is constantly shedding enormous amounts of material, surrounding itself with expanding clouds of gas and dust, almost as though it is slowly scattering pieces of itself into the universe. Ironically, this is the same dust that glows in infrared light and helped astronomers discover it in the first place. In a way, the star announced its existence through the very signs of its own death. Then one day, perhaps a few 100,000 years from now, a mere instant on the timescale of the universe, this giant will burn through the last of its remaining fuel. In that moment, the outward pressure that has held the star together for millions of years will collapse. Gravity will finally take over. The star's enormous mass will crash inward toward its own core at incredible speed, before rebounding in one of the most violent explosions in the universe, a supernova. For a brief time, that explosion could shine with the brightness of billions of stars combined. And when everything finally settles, this giant will be gone. In its place will remain either a neutron star, a mass comparable to our Sun, compressed into an object roughly the size of a city, or, if the remaining core is massive enough, a black hole, a region of space where gravity becomes so powerful that not even light can escape. The same star that was once so enormous it could engulf nearly an entire solar system will ultimately shrink into something no larger than a city, or disappear into complete darkness. Remember how, at the beginning, I told you that a monster had been hiding right in front of our eyes, and yet we never noticed it? Now you know why. You know just how enormous it is, how extraordinary its life has been, and how dramatic its ending will be. A star large enough to swallow nearly an entire solar system. A star so vast that light itself would need about 9 hours just to travel once around it. A star whose final moments may become an explosion brilliant enough to outshine entire regions of the galaxy. And perhaps that is one of the most beautiful and most humbling things about our universe. Behind every ordinary-looking star in the night sky may be a story far greater than anything we can imagine. Stephenson 218 reminds us that we have explored only a tiny fraction of our galaxy. Who knows how many more hidden giants are still waiting behind vast curtains of cosmic dust, waiting to be discovered. Before we finish, I want you to imagine one final thought. If Stephenson 218 really replaced our Sun, and you were standing on Earth as that enormous red wall slowly filled the entire sky, what do you think your very last thought would be? Take a moment and really think about it. I hope you learned something new today. If you enjoyed listening, I'd truly appreciate your support. Share this with someone who loves learning about space. And if you'd like to hear more stories like this, be sure to subscribe so you don't miss the next one. Until next time, take care.